Hello everyone, this is Priyadarshini, Assistant Professor in Kekewag Institute of Engineering Education and Research. And the objective of today's lecture is to study about the 4 pillars of IoT. So, let us study one by one. The first pillar is called as M2M. M2M is expanded as machine-to-machine communication. That is, one machine is communicating to another machine with less human intervention, or you can say without any human intervention. For example, vending machine, it automatically places the order when the stock present in it is very less. So, let us see about the architecture of M2M. The M2M consists of the M2M area network where all the M2M devices are connected by a LAN, and through a gateway they are connected to a communication network. The communication network, it can be a cellular network in the case of M2M, so that to support the large distance communication, and through that it is sent to the user or admin domain. So this is the application, this is the architecture of M2M. Now let us study about some of its application. The application of M2M is in various domains, and some of the domains are listed over here. The first is manufacturing domain. In the case of manufacturing domain, it is used for automating many processes. For example, it can find the in the case of manufacturing industry, it can find whether any product or any parts is fault, and if it is faulty, then it can automatically place an order for this faulty part. So likewise, for automation process, M2M applications have been used, and for smart home there are n number of applications. For example, remotely controlling your appliances, and whenever you are starting from your office to home, you can set the temperature at your home for a convenient level. These are some of the application of the smart home. The next is in healthcare device. In the case of healthcare device, the most important application is elderly patient monitoring system. So a patient, if he or she is feeling uncomfortable, or she is going to faint, and this M2M devices can detect it, and it can send an alert notification to the doctor. And it also has its application in the smart utility management, that is monitoring the energy consumption and alerting, and for bill payment and calculation of the reading. For all these purposes, the M2M application is used. The next important pillar of IoT is RFID. In M2M, again the machine and machine is communicating, but what is the communication network which is used is cellular network. All the 4 pillars which we are going to see, all are like machine and machine is communicating with each other. Then how they are differing? They differ only in the communication network. So previously M2M uses cellular network. Here in RFID, that is radio frequency identification, it uses the radio waves for communicating between the devices. So let us see about the architecture of RFID. The main thing in RFID is a tag. The tag consists of a chip and the antenna. So this is the architecture. The chip, it consists of a memory where you can store ID and some of the attributes. And it consists of an antenna which is capable of receiving the radio waves emitted by the reader. The first is what? The reader sends a radio waves, and this radio waves is picked by the antenna which is present in the RFID tag. Once it receives the radio waves, it starts emitting its ID or the data back to the reader, and the reader is connected to the host, and it decodes it, and it finds the data. So this is the overall architecture of RFID. This tag RFID tag, these are of three types, that is active tag, passive tag and semi-passive tag. Let us compare these three tags. In the case of active tags, there are battery. So, it doesn't rely on the reader to get energized. It can energize on its own. But in the case of passive tag, it cannot start on its own. It depends upon the reader radio waves. So, the reader emits the radio waves and to make this passive tags to be on. In the case of semi-passive tag, it also depends upon the reader, but how it differs from the active tag is that it consists of a small battery, but that battery is used for other purposes like monitoring the temperature. So likewise, for other functionality, it is having the small battery, but still it requires a reader to make it on. And the transmission range of passive tag is less when compared to the active tag. So it is only 6.096 meters, whereas for active tag can work up to 228.6 meters. So this is its range. And the cost of the passive tag is cheap as compared to the active tag. And in terms of memory, the passive tag is only read only. You cannot write into that chip again. But in the case of the active tag, it is read and write. Whereas the passive tag has large years of lifetime, that is up to 20 years. But whereas in the case of active tags, it is only 5 to 10 years. So depends upon the application, people select the tags. In the case of ID card and other things, you have a passive tag which is only read only, just you have to send the data. ID card person's information is stored in it. Now let us have a look at the tag, how it looks like. So this is this RFID tag you might have seen. So this is a chip part of it, and these are the antennas, and this chip consists of the ID and attributes of the tag, and these antennas are for receiving the signal which is emitted by the reader. And the chip together with the antenna, these are attached to the substrate. So this is how the tag looks like. Let us explore on the application. One of the famous application of the RFID tag is that fast tag. In the fast tag, it is used to pay for the toll without requiring to spending more time in waiting for paying for the toll fees. So car, no need to wait for paying for the toll fees. Instead, it is having a fast tag which is attached to it. This fast tag is a RFID tag. A reader is attached over here, and it continuously emits its radio waves, and when a car passes over it, this tag takes its the antenna present in the tags, it receives its signal, and automatically the toll fees have been deducted. So this is one of the application of the RFID. The second application is that for anti-theft, means anti-theft in the case of shopping. So you could have seen that in your shopping mall, these types of tags are present in your clothes. These are all for RFID tags to find the person who is taking away the clothes without paying for it. Sometimes you may also find this type of stickers. So this is also a RFID. Let us see how does it works. Here this is a person who is stealing a book or an item in which RFID tag is present over it, and he is not paying. So how it happens? So there are two gates. In this gate, a radio waves transmitter is there, and in this gate a radio wave receiver is there, and then it is connected to an alarm system, and there is a thief and who is crossing. So this transmitter is transmitting the radio waves, and when it comes in range with this product which is having the RFID tag, this RFID tag receives this transmitted radio waves and it starts emitting its signal. This is catched by this receiver, and if the frequency matches and it sends an alarm to the alarm system, and then the thief is caught. So this is one of the application of the RFID. In library also, in object detection, in vehicle detection, identification, in many more places, this RFID tag is used. It can also be tied towards the animal also to find its location, and so for many other purposes this RFID tags are used. The third pillar of IoT is WSN, that is wireless sensor network. So many sensors are attached, and all these sensors communicate with each other, and then they send the data to the base station, and then it is connected to the internet, and it is used for various applications. Weather monitoring, forest fire detection, all these are some of the example of wireless sensor network. The one of the most important application of WSN is body sensor network. As you can see, this person is carrying many sensors, and these sensors are there. They are connected by one a central node, and all, for example, you can find the heartbeat, pulse rate, and all these for different purposes. There are different sensor which is attached to his body, and all these sensor sends the data to this central node, and the central node is connected via Zigbee to the coordinator, and then they are connected to a gateway, and through the gateway they are connected to the internet. So likewise, underwater sensor and weather monitoring, forest fire detection, these are some of the application of the wireless sensor node network. The last pillar of IoT is SCADA, that is supervisory control and data acquisition. So this is mainly used in the industry. So in industry, within a building, there are many manufacturing plants are there, and if a person has to monitor everything, and if he wants to find if any fault is there in any plant, and then if you want to take a control action, then this SCADA is very useful. So this SCADA consists of the input to the SCADA comes through the sensors as well as the manual input, and it consists of the programmable logic control as well as RTU, and this units receives the input from the sensors. So after receiving the input, it processes it, and the processed data is represented in the form of graphical representation, so that if there is any fault in any devices, the operator can find where is the fault, and it can be communicated, and or it can be rectified. So this is an application of the SCADA. So these are the 4 pillars of IoT, that is M2M, which uses the cellular network. The next is RFID, which uses the radio frequency for communication. Then WSN, which is consisting of sensors is widely spread, and the next is SCADA, which is within a building. So all these 4 are the main pillars of IoT. Thank you.